Hello and welcome back to Web Components Remote Conference. I'm still Justin, and the building has not been blown over by the wind. We are now here with Jan. Oh, gee. Leon, I know you're watching, Leon. Why did you give me all the people with the hard names at the top of this? Jan, it's good. It's good to see you. Jan's going to talk about the challenges and payoffs of building general purpose web components. Jan, it's so good to see you again. I will let you take it away.
All right. Okay, thanks a lot, Justin. So hello, I'm Jan Miksovsky from Component Kitchen, and I'm excited to be here. In this talk, I'd like to make the case that the reusability of a web component depends heavily on the quality of its fundamentals. So before a component can do anything special or amazing, it needs to get the basics right. And being able to share reusable components is an exciting shift in application development. It's going to let us create more powerful applications more quickly, but delivering on that theoretical promise is going to require substantial work. So in this talk, I'd like to look at this issue of component quality as a necessary condition for component reuse. And I'd like to present 4 ideas for you to think about. So we have, at the basic level, I'm going to talk about expectations that developers and users have for components. I want to talk about the gold standard checklist for meeting those expectations. I'll present an implementation strategy for code that wants to aim at that checklist, and then a new open source project making web components this way. So let's talk about expectations first, because I think we need to start here. You may have a component that you've created for an application that you're working on, and you want to make it available to the public at large. For that component to be successful, it's going to need to be able to meet a much broader range of developer expectations and the expectations of the users of other applications. And you need to factor that into your thinking to consider how to take the component that you created for one context and make it broadly reusable. How hard could that be? Let's look at just, in this talk, we're going to look at a simple single selection list box. This is the kind of thing you're all familiar with. The user has this expectation that they can click on an item to select it, and if there's a lot of items, the list can scroll. So that's going to be the component we want to create, and we're going to study that component from a variety of angles to think about how to make that high quality and generally reusable. We'll start by looking at developer expectations for this component. So there's the basics. A component should have an API and all the key user features, everything the user can do through that UI, the developer should have access to. They want to be able to read and write state. They want to get events when things happen inside that component or the user interacts with it. These are the basics that we start with, but we can get into a lot more detail. So let's look at developer expectations for, say, content and the way the component is going to manage its light DOM content. So most components will have content. In this list case, we want to have the items of the list as the children of that component. Maybe we've designed this component so that it can work with any type of, or we've designed it to work with divs and strings as the list choices, but we want it to work with any type of child because other developers may want to put images in it. They may want to put other custom elements. So we need to be able to cope with anything. We also need to cope with nothing. So someone may instantiate this component for some reason with no children, and they're going to come back later and populate the component children at runtime, and our component needs to handle that. It can even be hard to figure out exactly what we mean when we talk about a component's content. When this list has children that we want to present as choices, that can actually get a little complex, even in sort of common cases. So if we have, say, a list box, and it's going to extend HTML element, we're going to do this all in plain JavaScript. And we have some initialization that the component wants to do in its connected callback or in a slot change. And in this case, it wants to initialize each of its lifetime children by setting an attribute on them. So it wants to some kind of processing on each of its children. So this code, this is a good place to start, but this isn't sophisticated enough to cover the range of what developers might want to do with this component in their applications. So let's look at this. Here's a developer who said, hey, it's legal for me to put a style element inside of a component. I want to put a style element inside of a list box to style those items. And maybe that's something that you hadn't anticipated, but that's something that the component should handle. And the simplistic initialization code that we've got isn't going to cover that, because it's going to try and treat the style element as if it were a choice in the list, which is incorrect. There are other kinds of child elements that are invisible. They perform some function. It could be a script tag, a link tag, a template. Those are the kinds of things that this component's going to need to take care to avoid presenting as if they were choices in the list. When we get to web components and Shadow DOM, there's more complexity. So let's imagine that there's a developer out there that wants to use this list, and they're going to compose it into some other element that they're creating. So they want to take this list box, stick it inside of the Shadow subtree of this other element. And the other element is it has a slot, and it's going to stick the slot inside the list. This is a pretty powerful way to compose components together. So the children of this other element are going to end up being items in the list. But for that to work, this list box has to get a lot smarter. Right now, the list box is processing its direct children. And when it looks for its children, it's going to find that it has a slot, and it's going to try and set an attribute on the slot itself. Again, that's incorrect, and the component's going to have to do work to correct for that. Moving on, developers have expectations for properties and attributes, and these get pretty sophisticated. So to start with, in your use of a component, you may have always been setting properties on it, but when you give it to someone else, it would be nice if they could instantiate it without any properties, just the plain tag, and get something useful. They should only have to set the properties that they need to. That means you have to take care to set good defaults. You want to let a developer set those properties in any order, and they shouldn't have to invoke some kind of refresh or update method to get that component to do its trick. The component should be updating with each property change. As those properties change, the component should be raising property change events. And let's look at that in a little bit more detail, because again, it gives a sense, it sort of conveys some of the flavor of what it's like to try and create components that are robust. Here we have in our list, let's say that it's going to have a getter setter for the selected index, the index of the selected item in the list. And in the setter, we'll save the value that's been passed in, and then we'll raise an event to let people know that that index property has changed. So in the code below, when we set selected index to 1, that will raise this property change event. The question is, should it? The answer may surprise you. It surprised me. If we look at standard input elements as an example, if we create a checkbox and add it to the DOM and set its check property, that will not raise a property change event. If the user clicks on the checkbox, it will raise a change event. But when we change the check property with our own codes from the outside, it doesn't. And the thinking there is that the browser uses events to let your outside application code know what's going on inside the component. In this case, the checked property was set by your application code. So the browser concludes that it doesn't need to tell you about that change. You know about it. You were the one that made the change. So it's not going to raise an event. That helps it be more efficient. There's not as many events generated. And so for your component to really behave like a standard element, it's going to need to be that sophisticated. There are many other expectations developers may have for your component. There's not enough time to go into all the details, but the basic idea, you can sort of summarize it by saying, anything that's stylistically possible, a developer will probably end up throwing at your component, and your component is going to need to do the best it can with it It's going to need to do something sensible, and it should never crash. So that's the goal. Users have expectations, so let's talk about that for a minute. They have this basic need in this list. They want to be able to click or tap an item to select it. But let's look at keyboard support. That's a pretty interesting expectation for a component like this. In a client OS, those can be navigated with the keyboard. Even in a mobile-first world, a user may have a Bluetooth keyboard paired with their device that they'd like to be able to use. There's an important accessibility concern here. There are users that have limited motion. Maybe they can't use a pointing device like a mouse or a touch, and so they're relying on the keyboard. And the users may also be people like you. They may be power users that are quite sophisticated and appreciate the efficiency they get by being able to use the keyboard because it'll be faster. So there's a set of keys we want to support here. There's a little bit of complexity in all of this, but some of these actually raise some pretty interesting questions. For example, let's look at page down. How does that key actually work? So I'm not gonna, if you're watching this on a device and you've got a keyboard handy, don't do this yet. Just keep your hands off the keyboard. But try to imagine what's gonna happen if users in a list like this, and the focus is on the list, they've got an item selected, and they press page down. What's gonna happen? Your answer will depend probably on which client operating system you use. And I'm going to leave this as a little puzzle. There are two competing user interface models for what should happen with page down. There's one that's very simplistic and I argue somewhat useless. And then there's a subtler one that's more useful. And I want you to ponder that for the next 15 or 20 minutes, and then we'll come back and talk about which might be better. The point here is that there's complexity. The complexity isn't obvious, and it takes some time to get this kind of detail right. As I said, keyboard use is an accessibility consideration. There are others. If you've never sort of dived into the topic of accessibility, I encourage you to stay with the conference. Later today, Rob Dodson's going to be talking about building accessible web components, which is a critical thing for all of us to be thinking about, especially as we're building components for reuse. Regardless of what you think about your user community and whether they need accessibility or not, the developers that want to use your component absolutely care about that. And so I think it's important for all of us to be aware of that. For this talk, let's just touch on one aspect of this, which is that through a spec called ARIA, this list is going to want to communicate to a device like a screen reader what kind of component this is. Is it a list? What's the list for? How many things are in the list? And some descriptions of those items. And the way this is done is with attributes. So if we have a simple, a developer has created an instance of this list box in markup, and they put in these choices. At runtime, what we'd like is this component to annotate both itself and its children with attributes like this, so that the accessibility features of the browser will be able to communicate to a device like a screen reader exactly what's on the screen. Again, very little of this is obvious and maybe unfamiliar, but this is another critical detail to get right. And at some point, you might ask yourself, you know, why do I have to think about all this stuff? And you know, what's the total set of things that I should be thinking about? Because there's a lot of detail here that maybe you or other people you work with don't think about all the time. And that's a real challenge. There's essentially a missing manual. We have in web components a set of specs for the browsers that let us register new elements through browser APIs. That's great, but that doesn't tell us anything about how to meet developer and user expectations for those elements. It doesn't tell us what they're supposed to do. It gives us lifecycle callbacks, et cetera, but it doesn't tell us what we're supposed to be doing in those callbacks. So this leads to the second idea I want to cover in this talk, which is the gold standard checklist for web components. Raphael mentioned this earlier this morning. This is a checklist that got started about 2 years ago, trying to consider the question, how can we make custom elements as good as the standard HTML elements? So let's look at that in a little more detail. So the checklist uses HTML elements as the gold standard for behavior, because that is what people are familiar with. Devs know HTML, users interact with it, and they expect new elements, both at the UI level and at the API level, to behave like the standard HTML elements. So that's that's a very good place for us to start in figuring out how something should work. When we first started working on that checklist, it turned out we could not find a resource that told us everything that would go on it. So a lot of this is reverse engineering. What is it that standard HTML elements do, making a list of that, and then turning that into a checklist. You can find the checklist on GitHub in the org for webcomponents.org. And the checklist is divided, it's about 60 elements, 60 items in the checklist spread across 10 categories. I'd encourage you to take a look at that after this talk. If we look at just one example, this is a checklist item for tracking content changes. This is something I mentioned earlier in the talk that a component should do. It should keep track and respond appropriately if a component's children change at runtime. And this checklist, it's an open community project, so it's still has a long way to go. But the goal is that for each item on the list, we would eventually like to have an article behind it that describes what the item is, why it matters, and what code you might write to comply with that criteria. If you look through all of it and consider all the code required to meet those criteria, it turns out to actually be pretty hard. There's a lot of arcane knowledge. Could be keyboard support, could be accessibility, could be many other things. And there is a substantial amount of code required to meet all the criteria that might apply to the component you want to create. So that's the bad news. The good news is that many of the checklist items are orthogonal or independent. So what we can do is actually look at the items on the checklist, consider them in isolation, and think about the code required to meet those criteria. And if we had a way to implement that code in a modular fashion, we could combine that code to create a component that would meet the checklist. So this gets to the idea of component code reuse, but at a deeper, finer grained level. So we're talking about here reusing code inside of a component. An analogy I sometimes like to use is to compare components to molecules. So a molecule is something that can exist in the real world. A component can exist in the browser. You can interact with it. But just like molecules, the behavior of a component is reducible to smaller pieces, handling different aspects of its behavior inside of the component. And the cool thing is that we can write reusable code at that atomic level too, and that's going to save us a lot of time. So that leads to our third idea for this talk, which is an implementation strategy for building that kind of reusable, fine-grained atomic component code. And the goal here is to try and find a pattern in JavaScript that lets us compose complex behavior without a framework. The point about framework there is, we'd like to be able to build something that's broadly reusable, and so we don't want to depend on a component being written in any particular way in order to get the benefits of this kind of reuse. So we'll look at mixins as a strategy for doing that. Mixins have a mixed history in JavaScript. if you've seen old school mixins, they often look like this. There'll be a bag of properties, and then depending on what framework you're using, there'll be some kind of class factory or class constructor. You'll hand it an array of mixins. If you're not using a framework, you do this code yourself, but essentially you're creating a framework for yourself. And every framework is going to need to make some decisions about how to reconcile anything. For example, there might be naming conflicts across the properties and methods defined by the mixins, and each framework has to make some decision strategy for that. When they're done, you end up with this class that you can instantiate and then poke it to get it to do its thing. That's cool, but there's some challenges here. As I said, we'd prefer to avoid using a framework if we can avoid it. And there's not enough consistency across frameworks for how these mixins might behave that would let us write a mixin once and reuse it anywhere. So we'd prefer to find an alternative pattern. And one intriguing possibility is opened up in ES6 with class syntax. And rather than using a framework, we can employ a new JavaScript idiom, which we can call a functional mixin. So let's look at this for a minute. Not a lot of code, but it may be doing something you're not familiar with. So this is a function that's going to take a base class, and it will return a subclass of that base class. And that subclass will be extended with the mixins methods and properties. So if you pass an object class to this, you're going to get a new class back, and it's going to know how to greet. So we can apply this to anything. There's no baked into the mixin or no preconceived notions about what the base class passed in has to do. So here we can apply it to a base class like HTML element to create a greet element, and then register that. So you see here it's extending greet mixin applied to HTML element. So that's what's going to get registered with the browser, and then we can instantiate that and then have it do its greet trick. So this is, the interesting thing here, this screen of code is doing the same thing that the previous screen was doing, but there's no framework in the picture. It's just JavaScript. It's an idiom, so it may be it's a particular way of using the language that might be unfamiliar to some people. But if you know JavaScript, you can sort of puzzle out how it's doing what it's doing. And that's a pretty important property. Now, I mentioned earlier that the framework had to, frameworks that use mixins have to do things like handling naming conflicts across properties and methods. So we still have that problem. The way that we're going to solve those in functional mixins is to rely upon the mixins doing some more work by following a set of conventions. So the first convention that I want to talk about is being able to cooperate by having mixins propagate property and method calls up the prototype chain. So if two mixins implement the foo method and the foo method is invoked on an instance, what those mixins can do is they can give their superclass, that is someone further up the prototype chain, a chance to do their foo work, and then they can do their own. They need to, this is a little unusual sometimes, to see a conditional invocation of super. The reason for that is because we don't know anything in our mixin about the base class this mixin is being applied to. It might have an implementation of foo, or it might not. So if we were to just do always invoke foo, in certain cases that would break if the base class didn't actually implement that. So we do a conditional check, and if foo exists, then we invoke it. The other thing that we want to do by convention is, where possible, we'd prefer to have methods and properties used by these mixins identify those methods and properties with symbol identifiers instead of string names. String names are fine if you expect fully that the property, for example, being defined is going to be exposed as part of the component's public API. But if it's for internal use, maybe to communicate between mixins, then we want to make that identified with a symbol, and that'll keep it hidden. So let's look at an example. We're going to take just a couple pieces of this list box and implement those with mixins and try and do that in a gold standard kind of way. So let's handle clicks. The user is going to click on an item, and then in response, we want to remember which item they clicked on, and then we want to apply appropriate ARIA attributes to expose that selection to a screen reader. And we'll break that up into this particular set of expectations. We'll break up into 3 mixins. The first is going to handle clicks. So this is an application of this functional mixin pattern I just showed. There's more work that it has to do than I'm showing here, but I just want to focus on one part of it, which is it's going to listen to clicks. When it gets a click, it'll figure out which item was clicked on, and then it's going to set that as the list's selected item. And it'll do that with a property setter. That property actually isn't defined by click selection mixin. That's going to be handled by other mixins or by the final component itself. So in this case, we're going to handle that in 2 different mixins because we have 2 different kinds of effects that we want to have happen. So a lot of here, I'll talk through it. There are 2 mixins, one to handle tracking which item is selected, that's on top, and then one to apply part of the attributes that ARIA needs. They both implement a setter for selected item, and they both take care to follow this convention of conditionally invoking any selected item setter further up the prototype chain. The top one also does some work. It's going to remember which item was selected. The bottom mixin here is going to set the ARIA active descendant attribute on the list and point to the ID of the selected item. So these 2 things can work together. They have an emergent property that's not perhaps clear from the code. By virtue of the way these mixins are defined, they have a pretty cool ability, which is that it doesn't matter in which order you apply these mixin functions to the base class. So you can puzzle this out later, but the basic idea is regardless of whether you first hand your base class to the single selection mixin and then to the ARIA mixin, or you do it in the other order, regardless of how those mixins extend the prototype chain, the final result will always be the same. And that's pretty important because we don't want to have to think about that. When we're applying mixins, we don't want to have to do that in a specific order. So we're going to now do that. We're going to apply the mixins to this base class of HTML element. Because the order doesn't matter, let's do it in alphabetical order, just to keep things easy to follow. And then we'll instantiate that. If we take a look at a demo, so here I have an instance of that list. I've also, just so you can see what's going on, I've added a piece of code that'll highlight the selected item again in the same kind of way. And if we look at what's happening in DevTools, as the user clicks the items, the ARIA active descendant attribute and some other ARIA attributes are being updated in response. So this whole chain is working. The click selection mixin is tracking the clicks, and then the other mixins are updating the selection state, including support for ARIA. Let's look at some other mixins that might be used in this list. To comply with the gold standard checklist items related to handling content, we can use a couple of mixins. One is going to handle slots that might be in our element and help expand those out. And then going sort of the other way, we want to filter out the stuff that we don't care about. For example, the style tag that I showed earlier. So we've got some other mixins to do that. And then a set of mixins to handle the keyboard. This is pretty fine-grained. There's a lot of mixins here for the keyboard. And the reason for that is that we want to create this code so that it can be reused in a lot of different contexts. So keyboard keys, directional keys, say, like the up and down arrows, left and right arrows, we may want to use those in components that, other than lists. We may want to use them to do things other than select things. Maybe we want to have a component that is a pan and zoom component, and we want to use left, right, up and down to pan. So we'd still like a mixin that helps us wire up handlers for the directional arrow keys so that we don't have to go look up the key codes for all that stuff again. And then for something like selecting things, we want to be able to select stuff with a keyboard, but there may be cases where we want to select in other ways. In certain components, we'd like to be able to have directional gestures, for example, that if the user swipes left, we want to select previous, and if they swipe right, we're going to select next. So we break up all the navigation here into smaller pieces, and we can then combine them to get the results we want. Doing that lets us focus a lot more detail on the details of how each of these are going to behave. So let's take go back to the question I raised earlier. How should this page down key behave? So I'll go back to my list example. So I mentioned there were two competing user interface models for how page down and page up work. The simple one is we've got a viewport here. It has a certain client height. We can scroll it up and down with the mouse. And we're going to take that height. If the user hits page down, we're going to take that height and add it to the list's scroll top. That'll scroll the viewport by one client height. And so if I simulate that with my mouse here, it's going to, if I hit page down, I'd go, the list would look like this. And again, if I simulate page down, it would go like that. And so if I hit page down twice, this is where I'd end up. This did let me see further down the list, but now let's say I see the item that I want to select with the keyboard. After all, I'm using the keyboard. I'm hitting page down, and I want to get, I don't know, orange. So I hit an arrow key. And what happened? Oh, well, my selection was at the top of the list, out of sight, scrolled away. And when I hit the arrow key, it just moved that selection. And the list responded by scrolling all the way back up to where I was, which is pretty useless. So a subtler model for paging in scrollable elements is this. The first time I hit page down, it's going to select the bottommost visible item, which in this case is current. If I hit page down again, and I've already got the bottommost visible item selected, the code will figure out which item is one page further down and select that. And then it relies on the list's existing facility to scroll the selected item into view. So each time I hit page down, it scrolls further down. If I hit page up, the opposite happens. And the important thing here is that page up and page down here aren't doing anything to scroll the list. They're just adjusting selection. And the list already has this feature. If I hit the up arrow key, for example, it will scroll the list such that the selected item is completely in view. So page up and page down in this model are just hooking into that existing behavior. And this, as I said, I think is much more useful because it lets you quickly select with page down and then refine your selection with up and down. So let's go back to our more complete list box. We've looked at content mixins, keyboard mixins. We've got a component now. It's got 12 mixins. Just to kind of get started, that's a lot here. This might look a little overwhelming to see all these functions invoked. So we can, another alternate way to apply a lot of mixins like that is just to define an array of functions, and then we'll reduce that array by applying all of them against our base class. So this is another way that we can express the same idea. You could step back at this point and say, wow, that's a lot of mixins. Like, do we really need all that code? It's about 2,500 lines of JavaScript to implement the list box that you see here. Every bit of that code is there to meet somebody's expectation, a developer or user who's expecting this list to be a great HTML list box. So You could argue that, you could say, well, I want to leave something out. I don't need that thing. And if you're making a reusable component, that's tantamount to saying, I don't need to meet that person's expectation. And I think that that's presumptuous and is going to surprise people. For general reusability, I think I would strongly encourage people to think about making sure that the component does everything that people are going to expect of it. In specific contexts, that's the general case. In specific contexts, you might be able to omit particular things. So let's say you're building an application and you have a list. You want to use this component, but maybe your list is going to be short and it's not going to need to scroll. It's only going to have 10 items visible at any time. And maybe those items are never going to change. So you're using a list, but you don't need the list to do all of its list box tricks. So we can create the same list and just leave out mixins we don't want. We can leave out the ones that are tracking content changes, and we can leave out the ones that handle scrolling. And now we'll get a smaller component. So this is a pretty cool idea, but keep in mind, this is what you might do for a specific application where you know a lot more about context, and therefore you know a lot more about what people are going to expect that component to do. Overall, I think that this is a pretty challenging prospect to try and create components this way, because there's a lot of details here. And frankly, a lot of them are pretty boring. Like, I wouldn't encourage or expect teams across the world to spend a lot of time sweating these details. It's reinventing the wheel, as Raphael said earlier. I like this quote from Jeff Atwood. Don't reinvent the wheel unless you just love learning about wheels. Wheels are pretty boring. They work. We should just use wheels made by other people. So that's, I think, an interesting thing to ask. Well, what if we had a library of mixins for all these common aspects of component behavior that would let us meet the gold standard for web components? What if we used that library of mixins to create a library of pre-built components? If we didn't, we just wanted to get a good example of a working tab strip or a menu or a dialogue. And what if we accepted the challenge and ambition of trying to meet all the expectations? We want to meet every developer and user expectation when we're building a user interface element that we expect to see used broadly. So that leads to the fourth idea and last thing I want to talk about for this talk, which is I'm very excited to announce make the first public announcement of an open source project called Elix. This is a library of general purpose web components. They're built with mixins. There's a library of mixins that are used to make both the Elix components, as well as they're made available to you to make your components. And all of this is done with the idea in mind that we want to meet the gold standard to the extent possible. More importantly, we want this to be an open org. So, it's one thing, to put open MIT license on this, which we've done, and that's cool. But we think that this is really going to benefit by having an open governance model. So we've been inspired by groups like the people behind Yarn or Ember. There's a number of projects that have what's called an open RFC process, a request for comments process. So that means that anyone can participate in moving the project forward. So both members of the public and members of the project core team, all changes get proposed through request for comments. So everybody has a chance to influence the direction and to help move that project forward. The project core team includes members from these companies, some of whom have spoken at the conference already today, and many you're probably familiar with. So this is who's behind it. We meet on a regular basis to review those RFCs and sort of guide the project. We're just getting started. So Elix came together late last year. We've been meeting for about 2.5 months, and we've accepted a set of proposals for both the functional mixin architecture described here, and some of the mixins that I've described. We have an initial set of mixins for the list box and list-like elements. That includes things like tabs and carousels that share a lot of code with lists. So those are, a number of those have landed, and many more are in flight. You can follow along with our work on GitHub and Twitter account Elix Elements. So I'm very excited by this. It's something that's I've been looking forward to announcing for a while. So and I think it's appropriate. Our core team, we do all our meetings remotely, so it's only appropriate we launch here at a remote conference. A couple things I'll leave you with. This library Elix is meant to be a library of components. It's not meant to be a framework per se. Instead, we want to do things in such a way that we work with the existing frameworks that have a relationship to web components. So let's talk a little bit about Polymer and React. Polymer and other frameworks, any framework that has a well-behaved ES6 base class is something that we'd like to support with the Elix mixins. So a good example of this in Polymer 2.0, which will come out shortly, they have a base class called Polymer.element. Polymer.element handles a bunch of fundamental responsibilities like populating a shadow root, marshalling attributes, things like that. As it turns out, Polymer.element is written with functional mixins, so they use the exact same pattern that we're using. We're just, Elix is providing sort of higher level mixins that deal more with user interaction. So we can take the list box example that we've been developing. If you recall, all of the mixins here are getting applied to the base class HTML element. We can replace that with Polymer.element and get pretty much the same thing. We even get to take some code out because Polymer.element handles some aspects of the component's responsibilities here, like populating the shadow root. We can comment out that mixin. And then the result is we get a component that looks like this. Looks pretty much the same. It's got arrow keys and page up and page down. But this built with Polymer. So if you like working in Polymer and you want to have access to its facilities like data binding, then you can do so. We also want to support React and Vue, the other FRP or virtual DOM based systems for composing UI. Those React and its ilk work with HTML elements, and they, as long as an element is well behaved, React should be able to work with it. And it turns out that in order for a web component to work well in React, it needs to do certain things, or it needs to make some guarantees. For example, if the virtual DOM engine is going to be appending and removing children inside of a component, that component needs to respond to runtime changes in its content, which is exactly that content changes checklist item that we already covered in earlier in the talk. So the goal is that if you create a component that complies with the gold standard checklist, then by default, your component should work in React. That would let you do something like this. You can create an application that is in React, and you could drop in this list component, this list box component. You could populate it, and the virtual DOM engine will take care of rendering that. Demo of that, here's a React application using that list. I have the keyboard support and click support. There's the ARIA support. All of that's being made available to that React application. So there's a lot of ground to cover in this talk. I've presented it as 4 ideas. And you can, one reason I did that is because I'd like you and your team to think about sort of adopting as much of this as you think would be relevant for your team. You might start by just looking at the expectations that developers and users have for components. You might think about looking at the gold standard and using that as a reference for informing your study of expectations. You might go a little further still and say, well, we should compose complex components from smaller pieces and look at functional mixins as an architecture for doing that. And you could decide, we'd encourage you to look at Elix as a library of both mixins and components for building applications this way. Thank you very much. These are the some URLs to look at. There's the gold standard on top, and then beneath that is a link to the Elix org on GitHub. Thank you.
Hey, there we go. Maybe the toggle will work now. And we just lost Jan. But thank you so much, Jan, for that really super awesome talk. We were able to not take questions this time, but if you have questions, make sure you cover that in the talk and the chat down below. We're going to get ready to move on to our next session, which will start just in a few moments. So we'll see you in a second.